Training helicopter. The position of a training helicopter weight 2.75 times 10 to 5 newtons in a test is given by the position vector is 0.02 t cube I hat plus 2.2 t j hat minus 0.06 t square k hat. Find the net force on the helicopter at t is equal to 5 seconds. Okay, so in order to find the net force, of course, I have to find the acceleration. And therefore, since I know the position vector, let's start with velocity. Velocity is derivative of position vector dr with respect to time dr dt. So I have 0.02 t cubed, so that becomes 3 times 0.02 t square I hat, and then I have 2.2 t, that becomes 2.2 j hat, and I have minus 0.06 t square, that becomes minus 2 times 0.06 t k hat. So if I calculate this, I will end up with 0.06 t square I hat plus 2.2 j hat minus 0.120 t k hat. Now I'm ready to calculate acceleration. Acceleration is derivative of instantaneous velocity with respect to time, it's dv dt, and 0.06 t square becomes 2 times 0.06 t I hat, 2.2 j hat, derivative with respect to time is 0, and then I have minus 0.120 k hat. So if I calculate this, this becomes 0.120 t I hat minus 0.120 k hat. Now acceleration is given by this expression. Therefore, the net force, F net, will be equal to mass times acceleration. Mass is the weight mg divided by g, and I have acceleration a. So mg is 2.75 times 10 to 5 newtons. If I divide this by gravitational acceleration, 9.8 meters per second square, and I have the acceleration 0.120 t I hat minus 0.120 k hat. Okay. So now what I need to do is to substitute time into this equation, because I'm supposed to find the net force at t is equal to 5 seconds. So I can substitute in the net force F net, t is equal to 5 seconds. This gives me 2.05 times 10 to 10 to 6 in 0.12 parentheses. I have 5 I hat minus k hat divided by 9.8. So I've taken this into 0.12 parentheses and So substituting for time 5 seconds, I have here 5 I hat minus k hat 0.12, and then here this is not 6, it's 5, 2.75 times 10 to 5. And performing this calculation, I find the net force to be 1.7 times 10 to 4 I hat minus 3.4 times 10 to 3 k hat, which is given in newtons. So the net force vector is given by this expression. Okay. So as you can see, when it says try to calculate the net force, I need to know the net force vector because it has a magnitude and direction. So it can be written in terms of the unit vectors I hat, j hat, and k hat this way. Okay, so let's summarize what we did here. We know the weight of the training helicopter and we know the position vector as a function of time. We're supposed to calculate net force at a certain time. So taking the derivative of the position vector twice, acceleration is second derivative of the position vector with respect to time, or the derivative of velocity with respect to time. We obtain acceleration as a function of time. Then for the net force we need ma, but we don't know the mass of the helicopter, we know the weight. So the weight divided by gravitational acceleration gives us the mass, multiplied by our acceleration vector, which is to be evaluated at t is equal to 5 seconds. So taking this into 0.12 parentheses and substituting for t5, we obtain 0.125 I hat minus k hat for acceleration times the mass. This gives us the final answer for the net force vector, 1.7 10 to 4 I hat minus 3.4 10 to 3 k hat in newtons.